Okay, so how do you solve this with matrices? Well, what we want to do is what we're going to do is we're going to set up a coefficient matrix. Here, I'm going to abbreviate coefficient matrix. Then we have a variable matrix. That equals the constants. I'm going to abbreviate again. Okay. Now, what we're trying to do with this, just so you know, so let's say I had this equation, 3x equals 5. If we were to solve that, you would tell me I'm going to divide by 3. Well, another way to think about that is I could also multiply by 1/3. And the reason we multiply by 1/3 because that's the multiplicative identity, because those cross out and I'm just left with 1x. So that means I multiply both sides by 1/3. So what we do with matrices is we find the multiplicative inverse of the coefficient matrix. And we multiply that by the constant matrix, just like what I did here. And it's that easy. Finding the multiplicative inverse of a matrix is a pain in the butt, though, so that's why we're going to let software do that. If you take linear algebra or finite math in college, well, that's where you're going to learn how to do that. Right now, I just want you to be able to apply it, because it's so much easier than doing. I don't know if you remember doing this with Mrs. Bruckner or your college algebra teacher, if you're a CCV student, but it takes pages of work to solve that by algebra. So what we do is we're going to write the coefficient matrix, and so what you do is you just pull the coefficients of each of these numbers, each of these values, out into its own separate matrix. And a matrix is just rows and columns, right? So I see 3 rows, and these 3 variables, so I'm going to need 3 columns. So what I'm going to do is I'm just going to write 1, -2, 3, 2, 1, 1, then -3, 2, and -2. Do you see where I got all those values from? I just pull them off each term here. Now I'm going to write my variable matrix, and that goes x, y, z, and that will be a 3 by 1. 3 rows, 1 column matrix, and then we set it equal to the constants, and those are just the numbers that don't change, they don't have a variable with them off on the other side. So that's my matrix equation. So you need to write that, and then you're going to use software, and let me show you the software. Let me show you how I use that Math is Fun website. If you want to learn how to do this, if you have a TI graphing calculator and you want to do it, you click on that link, and there's plenty of videos that show you how to do it. This is the link that will open up that Math is Fun matrix calculator. So in that Math is Fun matrix calculator, do you see how I just typed in the coefficient matrix, and I just typed those in numbers there. Make sure you type them in correctly. That's the place. If you're going to get it wrong, that's how it goes. That's where you go wrong. Done it too many times. And then here's the constant. You see how I put the constant matrix in here as B? And then we'll just use those X, Y, Z values. That's going to be my answer. And you'll see it comes out as a column. So now the next thing, now do you remember back when I said we're going to multiply by the inverse? Remember back with that other equation where I had 3x equals 5, and I had to find the multiplicative inverse of 3, which is just 1/3. Remember, multiplicative inverse is what you multiply to get 1. Well, the calculator here will tell us that by, let's see, let me find it. Let's see, that's the original. And then, no, that's the one. What you do to get the inverse, here it is. What you're gonna press is you're gonna press this inverse of matrix A. So you get these numbers in, hit inverse of matrix A, and you'll see all this down below, which is a bunch of decimals. We can probably figure out what those decimals are, because they aren't that bad. Those look like 1/3, don't they? And then what you're gonna do is you press, because we want to be able to get that into something we can multiply. Whoops, that's not the one I want. This is the one I want. Then what you're going to press is you press 2A. You see that button down here, 2A? What that does, it takes these numbers in our last, that inverse A, and stores them into A. That's why they're saying 2A. Notice how these numbers are the same? Then the last step in this process, now we're going to multiply this by the constant side. And let me slide this off to one side so we can see what's going on here. So here it is. Then what you do is multiply AB. We're going to multiply this new A matrix, which is that A inverse matrix, times matrix B, and you have to do it in that order. Put this in A, times it by B, and that's the answer. So what that tells me is that these three planes, because that's what those three variable equations represent, is a plane, and where they intersect is at the point 3. At the point 2, -1, -1. So 2, -1, -1. Now, to make sure to know that you've got this right, to get this right, what you want to do is here. We're going to do this right here. We should take those values and substitute them in for each of the x's and y's. So I'm going to do 2 minus 2 times -1. You see, I said the 2 was x, the y was -1, plus 3 times -1. Is that equal to 7? Well, let's see. That's going to be 2 plus 2. Just a minute here. 2 plus 2. Oh, this should be +1. +1. Plus 3. Yes, that's equal to 7. See how I made that mistake I made? That's the z number, and that's, so I've just substituted for x, y, and z. Now, what you should do to make sure you're right is do it for all three equations. I mean, if you want to guarantee that you get the right answer, check it for all three. I don't bother doing that in this video because that's you knows how to do that. Now, do you see what's a little bit different about this one? Do you see how this equation doesn't have a or z number? So what we do for our matrix is you're going to do 2, -4, 5, 4, -1, and then we're going to do a 0 for the z because that equation doesn't have a z. And then -2, 2, and -3. So there's a 3x3 system. I hope I have a 3x3 system because I've got three equations with three different variables. So x, y, z. If you only have two variables, you can use a 2x2. That easy. So then we'll do our constants. Then you go ahead, go back to that calculator website, put that into A, put this into B, then do inverse A, and that'll find the inverse, and then then you click on that 2A, and then you do A times B, and then that'll get you the answer. So what I got on my calculator, I got -1/2, 3, and -4. So to see how I'm writing this as an ordered triple, on some piece of paper that I threw at you, it says ordered n-tuple. So we call it an n-tuple because this is an ordered triple. If I only have two solutions, x and a y, then we call it an ordered pair, an ordered two-uple if you want. If you have four equations with four variables, it's an ordered four-tuple or a quadruple, right? It'll be four. It'll A, B, C, D, and E, or X, Y, Z, X, Y, W, and Z, depending on what they're having for an axis. Okay, so that's that. Now, here's this last example. And what I'm hoping you see is I see 5 variables, X, Y, Z, W, and V. And they're in order. It looks like to get them in order for all of them. So that tells me I'm going to have, so there's 5 variables, but I've only got 4 equations. Oh, that's interesting. That's interesting. What was I thinking when I gave you this? Let me sit and do this one by hand. Let me come back. So I think I wasn't paying attention when I pulled this problem. One of the issues with this is if I've got 5 variables, I really need to have 5 equations to see if there's a unique solution. What might be happening here is there's not a unique solution, and I don't want you to have that. It wasn't the purpose of me doing this with you. So we'll just say I'm not giving you anything like that, so don't worry about it. What I started to do, just so you know, is I took this last equation, I solved it for V, so -5 minus 2y minus z, and then if I divide by 4, then I can substitute this back into those other equations and clear the fractions, but then I still have 3 equations with 4 unknowns. So there's a problem with this unless one of those variable planes are parallel. So I guess well, I don't know if they're planes if there's 5 variables. Who knows what represents 5 variables? 5 dimensions? I don't know. So yeah, don't worry about that one. I didn't ask anything like that. If the first 2 made sense, that's all you need to worry about. So what do you got to do? I mean, you probably can read this rather than me going over it. There's this multiple choice test that I have available here. What you do is just they give you 5 different systems. Write the variable matrix. Write the matrix equation was what I'm trying to tell you, and then you can use that matrix calculator, and then you can see the answer. Okay, and here's that same Math is Fun calculator. So like I said right here, show me the matrix equation on paper, and then write the solution as an ordered triple or pair or a quad. What's that would be called? Quadtuple, I guess. If there's 4 equations, 4 variables. I don't remember what the biggest one is. And yeah, and that'll get you ready for us to use this to do that partial fraction decomposition next.